In the last section, we spoke about a huge big gotcha around all this stream stuff whenever you're working with multiple stream builders that are watching for individual items coming across a single stream. So in this section, we're going to lay out a possible solution to all this stuff. Now, the solution we're going to use is going to be coming from the RX library. Remember, this is RxStart, which we've already installed and used inside of our project. We're going to take a look at some documentation. As a quick reminder, you can get to the documentation by going to pub.dartlang.org. You'll search for RxStart. You'll find the first result. And then you'll click on the API docs link over here on the right-hand side. Okay, so inside the Rx documentation, I'm going to go to the section of Rx transformers. And so we've used transformers before, but in each case, we were making use of transformers that we put together ourselves. So these are all transformers that have been already set up and configured to do very specific tasks given some specific stream. So inside this list of classes, I'm going to scroll down and find a very specific transformer. I'm going to go down, 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 and I'm going to find scan stream transformer right here. Okay, so I'll let you read the description yourself, and I'll let you go through the example yourself because, of course, I could read it to you, but you can read just as well. Essentially, what the scan stream transformer does is allow us to combine every element that comes along a stream. So if you want to, take a look at the documentation, but we're going to go back over to that diagram, and we'll talk about how we're going to use this kind of combination feature of this transformer to solve this big issue that we've ran into. Okay, so again, remember the big problem here is that every single time a new event comes across the stream builders rebuild, and they only get access to that most recent event. And so the thought behind using this scan stream transformer is that maybe we can figure out some way to take every event that comes out of the stream and kind of combine them together into a big collection of item models, so that every single time a new event comes across the stream, we'll add it into this collection, and then these stream builders will receive that big collection. And then each stream builder can look up its particular ID inside that collection and show that element on the screen. Now, verbal description doesn't do a whole lot for us here, so let's do this in diagram format. I'm going to drag a couple of items onto the screen here, and we'll kind of walk through this process. All right, so here we go. So we're still going to have our stream emitting individual item models. So we're going to get like, one at a time right here. This thing's going to come out. But before we allow it to go to the outside world, we're going to run it through this transformer that you and I are going to put together. So this is going to be our scan stream transformer. But I'll just leave it as transformer for right now. So this item model is going to come into this transformer. This transformer is going to maintain something that we will call a cache map. Now remember, in the Dart world, a map, focusing just on the map word right here, a map is almost identical to a JavaScript object. It's a collection of key value pairs. So when we first create this transformer, we're going to start off with an empty map. Then, as soon as it sees some item come through, or some ID right here, whatever it might be, whatever we decide to do right here, it's going to take the ID of this record, it's going to add it as the key to this map. So maybe this is item model with ID number 1. And then it's going to take the future with the item model inside of it, and it's going to add it as the value on the map. And let me make sure that thing actually shows up inside of here. There we go, much better. So the transformer is going to add the key and the value to this map that it is going to maintain inside of itself. And then it's going to take this entire cache map right here, and it's going to pass this down to each one of these stream builders. So now this first widget right here is going to look at the cache map. It's going to look at the key of 1 because it has ID 1, and it's going to get back the future with the item model inside. Stream builder number 2, or stream builder with ID number 2 and 3 right here, will look at the cache map as well, but it will see that it does not have a key of 2 or 3, and so it'll say, okay, I guess my turn hasn't come up yet. I'm going to stick around in my kind of ready state. So now item ID, or the widget for ID 1 right here, is happy. It's gotten the future that it cares about. So then at some point in time, maybe our stream now emits the future for number 2. So the transformer is going to take this one. It's going to add on a new key value pair right here with an ID of 2. And just to be really clear here, we are not like sequentially incrementing these. These are supposed to represent IDs. You know, just to make sure that's really clear, let's say this one is actually ID 99. So this is the item model representing item 99. So the transformer is going to look at that thing. It's going to add a new key to this of 99. And then it's going to stick that item model in for the value like so. So it's then going to take this new updated cache map and it's going to throw it down to all 3 of these widgets. Now, the situation is still identical to how it was before. This stream builder is going to see the new event, even though it already got the item model that it cared about. The stream builder for ID number 1 is still going to get this cache map and is still going to try to rebuild itself. But in this case, this widget or the stream builder is going to look at the cache map. It's going to say, oh, good, you've got my ID. You've got ID number 1. Well, I'm going to use this item model. And it's the same exact item model that it used before. So we still have the same behavior going on here. All 3 of these stream builders are still going to try to rebuild themselves every time they possibly can. The difference is that every time they rebuild, they're going to have the data that they care about right there at hand. And so we don't, let's say that maybe 2 right here is not 2 anymore. Let's say this widget is trying to show item 99 on the screen. And so now this stream builder will receive the updated cache map. It'll look at key 99. It'll see this item model, and it will use that to build itself. The same cache map will go to item number 3. 3 says, oh, well, I don't see my key in here. I guess I'll stay in my ready state. And so that entire process is just going to repeat itself over and over again. So that's how we're going to solve this problem. Again, this is a problem where anytime you have multiple stream builders that are watching for individual records coming out of a single stream, I really expect you're going to run into this problem. And so using this idea of a cache map of sorts with the scan stream transformer is going to be a very effective way of solving the problem. So with that in mind, let's take a break. We're going to continue in the next section and we'll get started on our block. So I'll see you in just a minute. In the last section, we had a long discussion about how we're going to solve this issue around multiple stream builders all listening to a single stream for individual events. So we're now going to flip back over to our stories block and start to implement this solution. So back over here, I'm going to first make sure that I have rxstart required at the top because remember, we want to use that scan stream transformer. So we've got it in here, we're good to go. So we're going to first start off by building the transformer by itself. I'm going to put together this transformer inside of a helper method inside of this class. So if we wanted to, we could absolutely define this in a separate file or whatever you want to do, but just to keep things a little bit simple for right now, I'm going to add this transformer to a method inside of stories block. So inside of here, I'm going to add on a method that I will call items transformer. And then inside of here, all we're going to do is construct this transformer and return it. So I'm going to immediately return scan stream transformer. And I'm going to open up my parentheses because we're going to have a lot of code that we write inside of here. So the first argument to this is going to be the function that gets invoked every time a new element comes in or a new data event comes into this transformer. So I'm going to add a function inside of here and put a comma afterwards. Then the second argument that I'm going to add into this thing is going to be the initial value for the scan stream transformer. So this will be some starting initial value. For us, it's going to be an empty cache map that we can add in these IDs to over time. So for the second argument to scan stream transformer, I'm going to pass in an empty map like so. So all we have to do is put on the curly braces. Now this is a great example of a time where we probably are going to want to do some type annotation to make sure it's really clear what the keys and the values are for this map. So I am going to add on my less than greater than signs. The keys to this map are going to be integers, and all the values are going to be these futures that will resolve with item models. So I'm going to say future, and I'll put it down another set of less than greater than signs, item model, like so. Notice that future is in an error state right here. We cannot make access to a future without first importing the async module from Dart. So I'll fix this really quickly by going up to the top of the file. And at the very, very top, I'll add an import statement for Dart async, like so. And then if I scroll back down, future, not an error state anymore. Okay, so now for this function right here, this function will be invoked every single time a new element comes across our stream. So it's going to have a couple of different arguments to it. The first argument you and I are going to call cache. So this is a reference to this map right here. It is the object that we're going to carry along through every single event that comes through our stream. So this is going to be persisted over and over and over again. We're going to receive this map right here that's going to start off as empty, and we're going to start adding in IDs and item models into it over time. Then the second element inside of here is going to be whatever is coming through our stream. So in the last section, when I was talking about how this stuff is going to work, with our stream and the transformer right here, I misspoke just a little bit. I had said that coming out of the stream right here was going to be an item model. That was not 100% accurate. A better way of representing this diagram would be to do something like this. You and I are going to put IDs into the stream, and this represents the ID of the element that we want to fetch. So our stream is going to just take that ID and it's going to pass it directly through to our transformer. So last section, I apologize for that. I had said that the item model was going to come into the transformer. That was not accurate. It's actually the ID that we want to fetch. So with that in mind, the second argument right here is going to be an integer. It's going to be the ID that we need to fetch. And then the third argument to this is something that you and I don't care about. So typically we call it index. This variable is an integer. It is the number of times that our scan stream transformer has been invoked. So it's the number of times that we've seen some event come into this thing. So in our case, you and I don't really care about this. So I'm going to replace it with an underscore to indicate, yeah, it's there, but we don't really care about it. Now, one other thing I want to mention here, if we want to, we can add a type annotation onto cache right here. At present, Dart thinks that it's a dynamic value, but as you and I very well know, it's going to be a map that contains keys of integers and values of futures with item models. So if we want to, we can add on a type annotation of map int future item model, and then I think we need just 2 closing brackets like so. Okay, so that's it. So now inside of here, we need to take this ID, we need to turn it into a future that resolves with an item model, and then we need to add all that stuff to the cache and then return the cache object. Because whatever we return from this function is what gets carried over to the next time this function is invoked. So to do that, all that stuff, well, let's take a quick break. We'll come back to the next section and we'll add in the code for it. So quick pause and I'll see you in just a minute. In the last section, we started implementing our scan stream transformer. So inside of here, we need to take this ID, we need to retrieve the appropriate item model wrapped inside of a future, and then add both those things to our cache object, which is a map. So to do so, we're going to say cache at ID. So this is going to establish a new key inside of our map, and then we're going to assign it a future that resolves with our item model. And that step is actually way easier than you might think. So quick reminder, we already put together our repository. It is an instance variable inside of the stories block. And so if we go back over to our resources repository.dart file, remember we've got a function inside of here that takes an ID and returns a future that resolves with our item model. So we already did all the work for that part. Good news. So back inside of stories block, right here, we'll say underscore repository, because that's what we called our local repository inside this file. Here it is right here, repository. And we're going to call the fetch item method on there, and we'll pass in the ID that this transformer just received. And then the last thing we have to do is return that newly updated cache object. The return statement right here is very critical because whatever gets returned from this function, remember that's what gets pumped in to this cache argument the next time the function is invoked. So we definitely have to make sure that we return this cache. All right, so that's it. That's our scan stream transformer. So all this thing does, it takes an ID, it fetches the appropriate item, it adds both the ID and that item to this cache object. So now our stream, which before was receiving this ID as an integer, it's now going to be emitting this big, gigantic cache map. And that's what's going to show up inside of each of our stream builders that are supposed to represent an individual item. So that's good progress, but we still have to make sure that we actually have a stream that can use this transformer, because we don't have a stream that's going to use it yet. We only have a stream for fetching our top IDs. And as a reminder, yep, no, not this diagram. Where is it? Right here. There's the top ID stream controller. So we need a separate controller that's going to manage the flow of items. So quick break, we'll come back to the next section and we'll start putting this thing together. In the last section, we put together our scan stream transformer inside of a items transformer method. However, we do not yet have a stream that can actually use this transformer. We do have a stream that represents our top IDs right here, but remember that is a separate stream from the item stream. So we don't have a controller that represents our ability to fetch items just yet. So we need to still add that thing in. So back inside my code editor, up here at the top of our block, I'm going to add in a new instance variable that I'm going to call items, and I'm going to make that a behavior subject. Now I want to give you a quick reminder on these subject things. Remember, they're essentially stream controllers that are created by the RxStart library. I still have my RxStart documentation open, so I'm going to pull up the documentation for the subjects section right here. You can find Rx subjects on the left-hand bar. So we just made use of a behavior subject for that new items stream controller. This is a special stream controller. It is special because anytime something new listens to our stream, the behavior subject will automatically emit the most recent data event. We also made use of the publish subject for the top IDs right here. The only special thing about publish subject, it is the normal same thing as a stream controller. The only difference is that its stream property is an instance of an observable rather than a stream. And remember, a observable is a stream. It's a observable that is implemented by RxStart. It is a stream that has a ton of added functionality on top of it. And so that added functionality is going to be important to us a little bit later on. Okay, so right here for items, we're making a behavior subject, and then I am going to annotate the type of this thing. So it's going to always be receiving an integer. That's what gets passed initially into this item stream. At some point in time, we're going to run it through our scan stream transformer, where that integer is going to be turned into a map. But that doesn't happen initially. So the first thing that the stream is ever going to see is an integer, and that's why we're going to annotate it with this type right here. Okay, so now that we got that together, we now need to make sure that we expose this new stream controller's sync and stream to the outside world, so that different parts of our code can add in IDs to be fetched and can receive back the cache map for use inside of all of our stream builders. So let's first take care of adding or exposing the sync to the outside world. So I'm going to add in a getters for, or how about two syncs. I'm going to add in a getter with the get keyword. We'll call it fetch item. And anytime someone calls this thing, I'm going to return items.sync.add. So add right here, this is a function. So we're going to return a reference to the function so anyone out there can call this thing. I'm also going to annotate the return type of this getter. So it's going to be a function that can be called with an integer. You'll also notice we got the green underline right here. It's because we have created a new stream controller, but we've not closed it at some point in time. So I am going to go down to the very bottom of the file where our dispose method is right here. And I'm going to make sure that I call items.close as well. Okay, that looks good. Now we still have to expose this stream on this items thing to the outside world, but there's a little gotcha around that. I know we've had a lot of gotchas lately. Unfortunately, this is one more gotcha. So let's take a quick pause and we'll talk about what the gotcha is around exposing this item stream to the outside world. So quick break and I'll see you in just a minute. In the last section, we added our items controller to the stories block. We then set up our sync right here, so anyone in the outside world or any widget inside of our application can access this getter and call fetch item with a new integer that represents the ID of the item we want to fetch. We still have to make sure that we expose this items stream to the outside world. But like I said, there's a little gotcha around that. So the gotcha is that the way that we had wired up streams previously, like when we first learned about blocks, and even the way that we wired it up right here, is not going to work in this very particular case. So let me write out the code that we would write if we were taking the same approach for exposing streams to the outside world as we did previously. So I'm going to put a comment on here that says, don't do this, bad. I'm going to remove this. So we might write some code that says something like get items, and this would be items.stream. But remember, we don't want to return just the stream. We want to return the stream after it has been transformed. And so we would really have to return items.stream.transform, and then pass in the items transformer that we just put together down here. So notice items transformer is a function. We have to call this thing, and it's going to return an instance of scanStream transformer. So right here, we would call items transformer. Okay, so again, this is what we did previously, and it's even what we just did a second ago. But in this very particular case, it would not work the way we expect. So here's why. Every time a widget accesses this items getter, this line of code right here is going to be invoked. And without a doubt, we are going to have many widgets inside of our application that are trying to access this getter. Because remember, for every one of these widgets that we want to have showing an individual item model, they're all going to have stream builders that want to watch that stream. So without a doubt, many widgets are going to be trying to access that getter. So every time one does, this line of code right here is invoked. Inside that line of code, we run items transformer. So items transformer right here is executed, and every time it runs, so for every separate widget, we create a new instance of scanStream transformer, and every instance gets its own separate cache. So that's the problem. The problem is that every separate widget that tries to access this getter will run this code, and every separate one is going to get its own individual cache object that is not shared with any other widget, which is, without a doubt, not ideal. So this is not the worst thing in the world. All it means is that we need to make sure that we only try to apply this transformer right here exactly one time to our stream. Very critical that we make sure we only apply this transform one time. So rather than setting up a getter for exposing our stream to the outside world, we're going to take a slightly different approach. So I'm going to delete all that code. Let's take another quick break right now. We'll come back in the next section and we'll figure out how we're going to expose the items stream right here to the outside world while only invoking that transform function one time. In the last section, we spoke about why we cannot use a getter with our new items stream controller right here. Because remember, we want to make sure that we only apply this items transformer exactly one time. And that would not be the case if we made use of a getter. So to solve this, we're going to add on a constructor function to our stories block. And inside that constructor function, which is only going to be invoked exactly one time, we will set up our new item, or we'll apply our transformer to the item stream. So underneath all my getters, I'm going to define a constructor function by saying stories block. And then inside of here, I'll call items.stream.transform. And I'm going to apply my transformer to this by passing in items transformer one time. Okay, so now one time, exactly one time, we call items transformer. That creates exactly one object, one map cache. So this thing right here, created one time, and then it's going to be reused for every single stream that's, or excuse me, every single widget that tries to subscribe to the stream. Now, one gotcha. Oh my gosh, I can't believe it's another gotcha. It really is. Okay, here's the follow-up gotcha. When we call transform on a stream, it does not modify the original stream. So when we call transform on this thing right here, this stream does not get modified. Instead, it returns a new stream. So a new stream is returned from this line of code right here. And that is the stream that we want to expose to the outside world. So we need to somehow take the stream that is produced by this line of code right here and make sure that everyone in the outside world can get access to it. So in order to do so, I'm going to add a new instance variable up here at the top. I'm going to give it the name of, how about simply items? I think that makes sense. And I'm going to declare the variable by specifying its type. So this is going to be an observable that will emit maps where the keys of the map are integers and the values are futures with item models. And I'll make sure that I get my right number of closing little thingies in there. And my mistake, I said maps right here, it's maps singular. Okay, so this is the instance variable that's going to hold a reference to the transform stream that we just put together right here. And so in the constructor, I will initialize the value of items by saying items equals blah, like so. Okay, so now anytime we create a new stories block, we immediately create a new behavior subject. We declare an instance variable of items, but we don't assign a value to it. Our constructor function is invoked. We take the items stream controller, we take the stream off it, we apply a transform to it exactly one time, and then we return that transform streamed and assign it to this items variable. And so now everyone in the outside world, all the outside widgets that exist, can all listen to this items stream right here. And that's it. So that's our stories block. Whew. So that's kind of challenging, not the easiest thing in the world, but we've now got something that's going to fit very well into this kind of setup right here. So we've now got our stories block put together, and we can now start to focus on our list view builder, which needs to have child widgets that have that stream builder and the future builder inside of it. So still a pretty good amount of work to do. Let's take a quick break, and we'll come back in the next section. Our list view builder is now attempting to fetch each item as it gets displayed on the screen. However, the builder itself is still returning a very plain text widget. So we're going to start to update that. Remember, rather than showing a plain text widget, we're going to want to show some new thing that we'll probably put together right now that's going to contain a stream builder that's going to listen to the item stream controller stream, and it's also going to contain a future builder as well. So I'm going to make a new widget that's going to house all the code for showing one of these very individual news items on the news list screen. To hold this new widget, I'm going to make a new folder inside my src directory, and I'm going to call this new folder widgets, like so. And then inside that new widgets folder, I'm going to make a new file, and we'll call this new thing, how about something like newslisttile.dart. So then inside that new file, we'll start to put together some code to get our stream builder and future builder put together. At the top, I'll first add in a couple of import statements. I'm going to get package flutter material.dart. We know that this file is going to eventually need to know what a item model is, because it's going to want to access an item model to pull off the title properties and whatnot. So I will import the models item model.dart file. In addition, I think that this thing is going to need to know about what a block is, because we're going to eventually want to access our block inside this file to pull the stream out and connect it to our stream builder. So I'm going to import up one directory blocks, and I'll get the stories provider.dart. You know, technically we don't need the whole provider here. We can actually get away with just the block by itself, only if we pass through the block into this child when we render it. But I think it might be easier to just make use of the provider and not where you have to be passing through the block itself. So we'll stick with the provider. Okay, so I think that's probably it for right now. So I'm going to now make a class that we'll call newsListTile, and that's going to be a stateless widget. And then remember, one of the very key concerns around this class right here, it has to know which ID it is responsible for looking for. So anytime the list view makes a new instance of one of these widgets we're putting together, the list view has to tell it, hey, you are responsible for showing item with ID 1 or ID 2 or ID 3. So I think that our newsListTile is going to have an instance variable that will be passed in from the parent as a constructor argument. So we're going to call that thing, we'll call it final. It's going to be an integer, and we'll call it the item ID. And we're going to say this is going to be passed in by the parent widget. Now to make sure that it gets passed in, I'm going to immediately define my constructor method. So newsListTile. And I'm going to make sure I take the item ID from the parent and have it forwarded to this instance variable right here. Okay. Next, we're going to make sure that you'll notice we have an error message here. It's because we've not put together our build method yet. So let's do that right now. I'll say widget build This is going to get called with some context. And then inside of here, as we said many, many times, this is going to have a stream builder that gets directly connected to our block. So without a doubt, we're going to have to get access to our block, which we'll do by making use of our stories provider. So inside the build method, I'll say final block is stories provider of context. Okay, so that looks good. Let's take a pause right here. We'll come back to the next section and we'll start putting together our stream builder and our future builder to show information inside this widget. In the last section, we started putting together our news list tile widget. We've hooked up the block to it, and now we're ready to make sure that this widget has a stream builder that listens to the stream that we just created inside of our block that specifically is going to emit items. So back inside of this new news list tile widget, I'll find my build method, and then from the build method, I'm going to return a stream builder. And remember what name parameters a stream builder has. We have to pass it a stream. So the stream that we care about is going to be from our block, and the stream that we care about is going to be that item stream that we just put together. And from that item stream, we're going to receive our map that has integers and future models. So into the stream property, I'm going to pass block.items, like so. In addition to the named argument of stream, we're also going to pass in our builder function, which is going to be called with a context and snapshot. Recall that this snapshot value right here wraps up whatever information is coming from our stream. So the first thing we're going to do inside of our builder is we're going to check to see if the snapshot has any data whatsoever. So I'll say if snapshot does not have data, so notice the exclamation right here, we're checking to see if has data is false. Then we're going to return, how about just a text thing that says stream still loading. Oh, looks like I forgot a comma. I'm going to make sure I get that in. There we go. All right, so now if we get past this if statement, then we can start to set up our future builder. So inside the snapshot is going to be our map. And in that map is going to be an integer with the future in the item model that we care about. Because we're working with some kind of complex data types here, I'm going to make sure that I annotate the type of snapshot right here as well. So I'm going to annotate the type as async snapshot that contains a map with keys of integers and values of futures that resolve with an item model. And then do make sure that you get the correct number of closing greater than signs. You'll also notice that future has an error right here. It's because we've made reference to the future type, but we have not yet imported the async module from the Dart standard library, which contains the actual future type. So to fix up that error, I'll go up to the top of the file and I'll add in import Dart async, like so. And now that error message goes away. Okay, so we got our stream builder in place. So now if we get inside of here, it means that we must have received, or at least if we get inside of here and pass the if statement, then it means that we have received our snapshot that contains that map of all the different integers and futures that we care about. So the next thing we're going to do is put together our future builder to look at that map and pull out the particular future that we care about and wait for it to go to its resolve state, where we can then access the data that we care about inside of that thing. So let's take another quick break. We'll come back to the next section and we'll start setting up our future builder. In the last section, we set up our stream builder inside of the build method of our news list tile. Now that we've got access to the big map inside of here that contains all of our integer keys and all the future item models, we can set up our future builder to look at the very specific future that we care about, and as soon as that thing resolves with some data, we can then take the data and render it to the screen. So inside of my builder, after our if statement, I'm going to return a future builder. And then for the future, I'm going to take the snapshot right here that contains the map. So I'll reference snapshot. The map that we care about is on the data property, and you'll notice that it correctly annotates the type as a map that has an integer and future. So the item ID that we care about was passed into this thing as a option to the constructor. And so we've got that instance variable of item ID. And so inside of our map, we can find the very particular feature that we care about by referencing item ID, like so. So then finally, we'll put together our builder method for the future builder. This is going to be a function that gets called with context, and this gets a snapshot as well. Now, because we have two variables here that are both called snapshot, I'm going to rename this snapshot variable as item snapshot, just to kind of distinguish between the two variables. I'm also going to annotate the type of this thing. So an item snapshot should be an async snapshot that contains a future, or excuse me, doesn't contain a future. We've already resolved the future through the future builder. So all it contains is the item model itself, like so. That's better. So now inside of here, we still have to check to see if the future that we've passed to the future builder has resolved. Remember, that's the whole purpose of the future builder. We don't know whether or not this individual item has yet been resolved or fetched from our repository. So we first have to check to see, in a very similar fashion to what we did up here, we're going to say if item snapshot does not have any data. So again, notice that we've got our exclamation right here. And it looks like I might have made a typo here. Excuse me, not data, I want has data. My apologies. So if we don't have any data on the item snapshot, that means that our item is still loading. So we can return some text like still loading item, and then we could print out the item ID, like so. Otherwise, if we have fetched our item and our snapshot does have data, then we can return some text that has some information from the item model itself. So at that point, item snapshot.data is going to be our item model. And as you might recall, our item model has properties like text or title right here. And so for us, we care about the title property the most because that's the actual title of the article that we want to display on the screen. So inside of this text widget, by this time, we've finally gotten access to our item model. And so we can reference item snapshot.data.title, like so. And forgot my comma again. That's better. All right, so at this point, I encourage you to do not refresh your terminal yet, okay? I want you to just pause for a second. We're gonna come back to the next section. We're gonna refresh the terminal together, and then we're gonna see whether or not this thing is working the way we expect. So quick break, and I'll see you in just a minute. In the last section, we just about finished up our news list tile. So the last thing we have to do around this widget is make sure that we actually wire it up to the news list. So in my code editor, I'm going to go back to the news list screen. At the top of the file, I'm going to import the widget we just created. And then we'll go down to our list builder and make use of the new widget. So back down here, here's the list view builder. We are currently returning text. So rather than returning text, I'm going to return a news list tile. And as the name parameter of item ID, I'm going to pass in our item ID, which is available as snapshot.data@index. So snapshot.data@index, like so. Okay, so we're now ready to test this out. Now, again, I ask you, please do not refresh your terminal, okay? Please do not refresh it, because if you refresh it right now, something really, really, really bad is going to happen, and I don't want you to have to deal with the fallout. So I want you to see what happens when I refresh my code. And again, I encourage you to not refresh right now because something very bad is going to occur. Okay, so I'm going to do my refresh. Now, unfortunately, as usual, it's going to take me a couple seconds. Okay, so there's the restart. Now look, I see stream still loading item, and whoa, what is going on here? Look at this. I'm seeing this constant error message scrolling all around. It's just these nonstop errors all over the place. So clearly something very wrong has occurred, but that's okay. There's one quick thing I want to show you, and this is going to seem a little bit mysterious, okay? So I'm going to flip back over to my editor. I'm going to go back over to my stories block. Here's the stories block. inside of here, I'm going to scroll on down to the items transformer. And remember, the third argument to this function right here, we had said was index, and that was essentially reflecting the number of times that the scan stream transformer is called. So I'm going to add in that index argument, and I'm going to print it out inside of here. Okay, so very small change. All we've really done is attempted to print out the number of times that we are seeing a value inside of our sync. All right, so I'm now going to flip back over to my terminal, and I'm going to try to do a refresh here. Okay, we're going to see some numbers log on the screen very, very quickly. I want you to look at those numbers as quickly as you can. So look at those numbers. You see that? That right there is the number of times that the scan stream transformer is being called. So I don't know if you saw it very clearly, but it went up to about 1,400. So in other words, right now, for some crazy reason, our scan stream transformer is seeing about 1,400 IDs come through here, even though, as you very well know, we don't even have 1,400 IDs to choose from. At the very maximum, we have 500 IDs. So clearly, something is going incredibly wrong with the scan stream transformer, or something up the chain. Something is going very wrong with maybe the items stream controller right here, or I don't know. Obviously, something is not quite as we expect. So, as you might guess, this is yet another, it's a gotcha! Hey, it's a double gotcha! Yeah, so it's a real big gotcha here. This is an awful, awful, awful gotcha in the world of streams in Dart. So, quick pause, we're going to come back to the next section, and we're going to talk about why we are seeing so many more events than we would ever expect coming through our scan stream transformer. So quick break, we'll talk about what's going wrong in the next section. In the last section, we tried refreshing our application, or at least I did, hopefully you didn't, and we immediately saw a crazy number of error messages on the screen. In addition, we saw something that made us think that our transformer right here was being called far more times or far more frequently than we ever would have expected. And so inside of our transformer right here, it was very clear that the transformer saw at least 1,400 events come through. Remember, we only expected to see one event per row that was being rendered on the screen. And so without a doubt, I would have expected to see way, way less than 1,400. So let's talk about what's going on. Now this is, again, so many gotchas. Oh man, so many gotchas. It's just another gotcha. It's just another gotcha. So let's talk about what's happening here. So here's a diagram of what's happening inside of our application right now. We have some number of news list tile widgets being created, and every one of those has a stream builder. Now, when we set up that stream builder and pass it a reference to our stream, the stream builder is listening on our broadcast stream. Remember, this is terminology that we used when we spoke about streams a while back. You'll recall that there are such things as a broadcast stream, and a broadcast stream can be listened to in an unlimited number of times. Opposed to a broadcast stream, here's the stream documentation. There's also a single subscription stream that only allows a single listener, but broadcast allows you to listen to it as many times as you wish. So every one of these stream builders is calling listen on that broadcast stream. Now really quickly, I want to look at the function on the stream that we're listening to called listen, like the actual function that is being invoked. So really quickly, back at my stream documentation, I'm going to go back down to my method section. And inside the method section, I can find a function called listen right here. So here's the listen function. If I look at the documentation for listen, you'll notice that it returns something called a stream subscription. Okay, stream subscription, that's interesting. Well, here's what's kind of going on behind the scenes. So every time one of our stream builders calls listen on that broadcast stream, a new stream subscription object is created. And so you can kind of imagine that we have some event that comes along here from our broadcast stream. So the stream says, hey, everybody, I've got a new event. Here it is. And so this event goes out to each of these different stream subscriptions, like so. The stream subscription then passes it on to the stream builder. Stream builder gets the information and it rebuilds our widget. So at this point, hey, everything looks just fine. Now here's the gotcha. You might be thinking that behind the scenes, if we add another little block in here that we're kind of omitting from the diagram right now, you'll recall that on our broadcast stream, we've set up that transformer. At least right now we've got one transformer. In the future, we might have some additional number. And so you might be thinking that when we call listen, or when the stream builder calls listen on the broadcast stream, the event object that gets emitted from our broadcast stream goes through the transformer and then travels on to the stream subscriptions. And each one gets their own little event, and they all get passed on to the news list tile like so. And so this might be what you think is happening. This is kind of, I don't know, it's what you would hope would happen, I guess. At least I was hoping this is how it would happen. But this is not actually what is going on. So let me tell you what is happening, and this will explain why we are seeing so many events inside of our stream transformer. Okay, so here's what's really occurring. Anytime our broadcast stream right here emits an event object, it does not first go through the transformers. This event object gets sent off to each stream subscription. So that each one of these gets its own separate little event object. Technically, it's all the same event, but it's just being forwarded to each one of these. So I'm showing 3 on here. There's really just the one data object, but it gets sent to every one. Now here's the problem. The stream subscription then takes the event object and it sends it through the transformers on the other side. And so this event goes to the transformers, and then it ends up going eventually onto our stream builder. And then that same event object, again, there's really technically only one here. After it goes through this first top path and ends up at the stream builder, the broadcast stream then sends it through the second stream subscription. So the event's now here. It goes on through the transformers a second time. That's the key, a second time. And then it gets sent on to the news list tile. And then the broadcast stream sends the same event to the third stream subscription, and it gets sent through our transformer right here a third time. And then eventually it ends up at the news list tile. So that is the issue. Every single time we call listen on a broadcast stream, it sets up a new stream subscription. And anytime that broadcast stream emits a new event, the event flows through each one of these stream subscriptions, and then it goes through the transformers on the other side. So in essence, inside of our current setup right here where we've got our scan stream transformer, this thing is being called way, way more than it ever should be called, because every time that we listen to that stream, and remember, we're listening to that stream many, many times. Every instance of news list tile that is created is listening to the item stream right here. And so every time we listen to this thing, that creates another duplicate event. And again, it's technically not a duplicate event. It's the same event that gets sent through the stream transformer an additional time. Now, in a normal stream setup, or if we had a little bit more conventional, simplistic setup of all of our streaming stuff, that would not be a problem. But we have a transformer right here that is doing some caching information along with a very serious network request right here. So for these incredible number of events that are coming from our transformer, normally if this was a normal application and we were just working with, say, text with no outside requests being issued, this would be okay. But for our application, every time that one of these events comes through here, like the 50 times that each one is, or the 30 times each one is, we are trying to make a network request or a request to our database with that, and we're trying to update some map right here. And so that is what is causing our application to go absolutely insane. We're getting this crazy number of duplicate events running through this transformer because every time that something listens to our stream, that creates a new stream subscription, and our event gets sent to each one and then to our transformer. Now, as a very quick example here, just in case you don't believe me, we're going to very quickly put together an example on Dartpad just to make sure that you believe me. And heck, I think it's really important that you see this stuff yourself to kind of develop your own engineering sense. So I'm going to import Dart async, which has all of our stream stuff. And then inside of here, I'm going to make a new controller. So this will be a stream controller, and I'm going to make it a broadcast controller. Very important. I'm going to make it a broadcast controller. And then I'm going to do controller.stream.listen. and we're going to listen to this thing multiple times. So I'm going to listen to it. We don't even have to do anything inside the listen function besides receive whatever data event comes through. So I'm going to listen to this thing like 4 or 5 times, however many times, 5 times right there. And then after setting up all these listeners, so remember each one of these creates a separate stream subscription, I'm then going to set up a transformer of sorts on my stream. So I'm not going to add a transformer per se, I'm going to use a map function, which is a transform of a sort. And so this is going to receive our event, and inside of here, I'm just going to print out whatever that event is. Oh, yeah, and I'll also return it, otherwise this thing might break. And then finally, after setting all that stuff up, I'll do controller.sync.add, and I'll add in the number 1 or whatever. Okay, so think about what's happening now. We've set up our controller. It's set up as a broadcast controller, which means we can listen to it as many times as we want. We then set up 5 different listen calls right here, which creates 5 different stream subscriptions. After that, I then set up a transformer of sorts right here, which means that every time we add some event to our stream controller, it's going to first travel through each one of those different stream controllers and then go to this mapping function. And so we're going to see this print statement right here print out 5 times, even though notice how the listen statements, they're not doing any printing. It's the map right here that's doing the only printing. And for some crazy reason, we're going to see this data event being replicated 5 times over. All right, enough talking. Let's do this. I'm going to hit run. And then in the output, any second here, oh, I must have made a typo in here. Okay, quick pause. We'll come back to the next section, and I'll give you a better example here. I know I made a small typo, so 1 second. We'll come back, and we'll take a look. At the end of the last section, I was so revved up that I made a little bit of typo in the very quick example I tried to give you. So notice here, remember every time that we apply a transform to a stream, it returns a new stream. So we were subscribing to we were listening to the old stream that wasn't actually getting mapped over. And so I fixed up the code here very quickly. I take the stream right here, I map it, which gives us back a new stream, which I call new stream, and then I'm listening to new stream right here. So on new stream, we are creating 5 stream subscriptions. And so you'll notice if I hit run now, we'll see printed out, well, basically what you see right there. You see 5 ones. So even though we're only adding in 1 single event right here, that event gets sent to every different stream transformer. And so map right here, this mapping function gets called 5 separate times, which is kind of unexpected behavior when you're first getting into this stuff. So obviously there's got to be a way to fix this, because there's no way we want to accidentally try to fetch all of our items like 1,500 times, of course. So let's take a quick pause. We'll come back to the next section and we'll figure out how we're going to fix this stuff up. In the last section, we had a long discussion about the real behavior of our broadcast stream. So remember, every time that we have one of our stream builders wired up to our stream, a new stream subscription is created. And so our event gets forwarded through each one and then forwards itself through all the different transformers. So right now, for every stream subscription we have, we are calling our scan stream transformer right here in additional time. Definitely not ideal at all. So in this section, we're going to set up a way of working around this that's going to be a little bit more how we would probably expect to see our scan stream transformer behaving. All right, so here we go. Here's what we're going to do. So we're going to introduce a new stream controller. And remember, when I say stream controller, when we actually implement this, we're probably going to end up making a subject. Remember, one of those behavior subjects from RxStart. So we're going to add in this new stream controller kind of upstream. We're going to call this new stream controller the items fetcher. And then we're going to hook up our transformer to that stream. We'll then expose this sync that belongs to the stream transformer to the outside world. So anytime that some component or some widget wants to fetch an individual item, it'll send the integer ID to this sync or this stream controller right here. That event will then go to our transformer. And then here's where the magic happens. We're going to wire up our existing items stream controller to take whatever comes out of this first controller right here. So the event's going to go through the transformer. It'll then automatically get forwarded on to our items output, which is what we're going to call the existing stream controller we have. And that stream controller is then going to take that event and send it to all the stream subscriptions, and thus eventually end up inside of our stream builder. So the key here, the reason that this is going to work, is that all these stream builders are going to subscribe or listen to this items output stream controller, and this thing is not going to have a transformer associated with it. So all these stream subscriptions right here, when the event goes through, there's no transformer on the other side for the event to go through. The event is going to go directly to our stream builder. The actual transformation process is going to happen way upstream, and the only thing that's going to be subscribing to this stream right here, or kind of listening to the events that come out, is this stream controller right here. So there's no duplication of events that are going to occur. All right, so that's the idea. That's how we're going to solve this. So let's take a quick pause. We'll come back to the next section, and we're going to start to implement this additional stream controller inside of our stories block. In the last section, we laid out our plan for solving this issue with our stream subscriptions duplicating events that go through our transformer. So I massaged this diagram a little bit to put on some of the different pieces of information that we're going to need for these two different stream controllers that are going to exist inside of our stories block. So we've already got a stream controller that's going to kind of continue to serve as the items output. We're going to continue to use the items behavior subject right here as kind of the central point that all of our different stream builders are going to try to subscribe to. We're going to add in this new items fetcher thing over here. Now this items fetcher is going to take an input of an integer. It's then going to forward that integer onto our stream transformer. So the transformer is going to take an integer and return our cache map. That cache map will then be forwarded on to our items output stream controller. So that's going to have an input of the cache map, and it's going to take it and just forward it on to all the different stream builders inside of our application. Because the stream subscriptions are listening, or all the stream builders are listening to this stream controller, and this stream controller right here has no additional transforms on it, there will be no duplication of events or kind of repeat events flowing through our transformer, as was the case before. So the refactor we're going to do inside of our stories block is going to be a little bit involved. So I do have to ask you, please watch kind of closely, because we are going to add and change a lot of code inside of here somewhat quickly. Now, to make sure that the refactor is going to go as smooth as possible, we're going to approach this in kind of like a top-down fashion. So we're going to start at the very top of the file with these instance variables, and then we're going to modify everything as we go straight down. So kind of a line-by-line approach. Okay, so let's get started. The first thing I'm going to do inside of here is I'm going to rename the existing item stream controller to instead be underscore items output. So this is going to be the stream controller that everyone listens to. This stream controller is no longer going to be working with integers. Instead, it's going to be working with this cache map, which is of type map integer future item model. So I'm going to adjust the type on there right away to be a map that has integers with future item model. And then I'll make sure that I get the correct number of greater than signs over here on the right-hand side. Then underneath that, I'm going to create a new instance variable that's going to be our items fetcher. So this is essentially the stream controller right here that everyone is going to pump integers into. And then we're going to eventually hook our transformer up to this thing. Okay, so here's our items fetcher. This is going to be a publish subject. And notice that I'm kind of inexplicably changing between publish subjects and behavior subjects right here. This is a topic that we're going to discuss later. I know that right now it's kind of frustrating how sometimes I'm using a publish subject and sometimes I'm using a behavior without seeming any reason behind it. Again, we'll talk about it in a minute. So the items fetcher is going to be working with integers. So I'm going to annotate its type as int, like so. Okay, so that looks good. Next up, you'll notice that we've got our items observable right here. We had created this solely as the kind of means to hook on to the output of the transformation down here. So we don't need this items instance variable anymore, because everything that is in all these different stream builders are going to be listening directly to our items output stream on that stream controller that we just made. So there's no longer any need for having this temporary variable to just hold on to the output of that transform item stream down here. So I'm going to remove that instance variable of items. Then we'll start to work on our getters. So for our getters, we're still going to want to have top IDs right here. And I'm going to add on a additional, let's see, getter for a stream. Yeah, we're going to add on one more. We're going to add on the observable that's going to be exposed from the items output right here. So this is how these stream builders are going to listen to that items output stream controller. So I'll add on observable. This is going to emit maps with keys of integer and future item model. I'm going to mark it with the get keyword, and then this will be called items. And again, this is going to be our items output stream. So items output dot stream. Okay, so there's the kind of the first half of our refactor. So we've now got the items output stream controller put together. We've exposed that thing stream to the outside world, and we've created the items fetcher. We'll now move on to our getters for syncs. So anytime that someone wants to add in an integer to be fetched, they want to get access to the sync of our items fetcher over here. So inside this getter of fetch item, rather than returning the sync that belongs to that old item stream controller, we want to give whoever's calling this thing access to the sync of the items fetcher. So rather than saying underscore items right here, I'll do items fetcher, like so. Okay, so now we're going to move on to our constructor right here. We're almost done. Remember, we had this before, this line of code right here, when we were wiring up the transformer to the item stream. That returned a new stream, which we assigned to the items instance variable. So that items instance variable is no longer needed, so I'm going to delete that entire line. And instead, we're going to set up this relationship right here. So we're going to make sure that our items fetcher has a transformer of the scan stream transformer, and then the result of all that gets automatically forwarded on to the items output stream controller. So to do so, we'll write items fetcher dot stream. We want to send everything that comes into the items fetcher stream, and we want to forward it to our transform of items transformer. So I'm going to wire that up inside of here. And then here's the magic. Everything that comes out the other side, that transformer, we're going to automatically forward it on to our items output. So everything that comes out of there, every single one of those cache maps, take the cache map, send it on into the items output so that it can then be used by all of our different stream builders. So to automatically forward all those hash maps on, or all the cache maps, excuse me, we're going to write pipe, and then we're going to write in the items output. All right, so this is the first time that we've seen a pipe function before. The pipe function is pretty straightforward in nature. It takes a source of events, or essentially a stream right here. So this is a stream. It takes every output event from that stream, and it automatically forwards it on to some target destination. So everything that comes out of items fetcher and its transformer automatically gets sent on to the items output. So then all of our stream builders listen to that thing, and they receive essentially everything that came out of this first stage right here. Okay, so I think that's just about it for our refactor. Now I'm going to scroll down. I want to just do a quick check here. I think that at the bottom with the dispose method, we have to do a little bit of cleanup here as well. So we need to make sure that we call close on the two new stream controllers we have. So we don't have items anymore. I'm going to remove that, and I will instead do items fetcher dot close and items output dot close, like so. All right, now at this point in time, I got to ask you, please look at your code editor and see if your code editor is telling you that anything is wrong. As you can see, my file looks like it's good to go. So if you've got any error messages right now, chances are there's a very subtle typo somewhere. So please take a look at the code I have on the screen right here and make sure that yours looks very similar to mine. Okay, so this looks a lot better. So we'll take a quick break. We're going to come back to the next section. We're going to test out our application again inside the emulator and make sure that this change has actually fixed our problem of all that kind of oversubscription stuff on the transformer. So quick break, and we'll test this out in just a moment. In the last section, we did a big refactor on our stories block. So we've now got this kind of central transform stream right here, and it has a single subscriber of items output. So anytime that the stream builder subscribed to that, single stream or a stream subscription is created every time, but there's no transformers on the other side that's going to cause those duplication of events. So I took the liberty of already refreshing my application. I'll do it one more time here. You'll recall that inside of my stream transformer right here, I was printing out the number of times that this thing got called. So if I now go check again, you'll see that my index only went up to 53, which is perfect. That's exactly what we want. That means that our scanStream transformer has attempted to fetch the first 53 items out of our top IDs. Now, as I start to scroll down on here, our item builder is going to attempt to render more rows. Remember what happens when that occurs. So here's our news list. I'm going to go down to my list view builder. So as the list view builder decides that it needs to render more rows, it's going to call the fetch item sync. It's going to pass in the ID to fetch. That ID is going to enter into our items fetcher. It'll go to the transformer. The transformer will do its bit. It'll assemble an updated cache map, send it to the items output, and that goes down to all of our stream builders inside of news list tile. So let's scroll down. I'm going to scroll down, and as I do, you see that just about equally as I see an additional item on the screen, I see one additional log statement over here. Perfect. And so that means that we are fetching the absolute bare minimum data to successfully show content on the screen, which was our overall goal all along. So this is fantastic. This is great success. This is exactly what we want. Now, I will point out that it looks like we do have one little error here. You'll notice how all these line items are all saying still loading item, blah, blah, blah. So it appears that even though we did set up our future builder inside of news list tile, remember inside of here, we were saying initially stream still loading, and then as long as the future builder was waiting on data, we said right here, still loading on item. So it looks like it's getting stuck in the state right here, and we're never actually getting a title to show. So let's take a quick pause. We still have a little bit of debugging to do. We'll take care of that in the next section.